Okay, baik. Assalamualaikum warahmatullahi wabarakatuh and a very good morning, afternoon or evening kepada semua yang melihat video. Okay, so hari ni kita akan masuk on our subtopic 3.7, electrical energy and power. So hopefully dalam this subtopic kita akan explore on how we convert electrical energy into actually heat. Kita dah belajar how, but basically what do we take into account when bila kita nak calculate the heat energy. Okay, sebab usually when you charge you punya phone ataupun you buat any application yang dalam circuit, usually it gets hot lah. Okay, sebab kadang-kadang the charge flow, and bila charge ni flowing through the electrical device, kadang-kadang electrical device ni will slow down this charge sebab electrical device ni ada ion dia. Okay, so when the charge hits this ions yang vibrating, okay, it will convert lah the electrical energy to heat energy. So we're going to look into that process and we're going to look into power. Okay, usually kalau korang beli apa-apa ada power sama dengan let's say 10 watts. Okay, so we're going to look at how we are going to calculate that lah. Okay, 10 watts. Okay, never mind lah watts itu. Right, so before we begin, let's look at our example circuit. Okay, so we have a circuit here with a battery, and the battery ni bila you pasang bateri akan ada normally akan ada electric field, and then the electron will go from negative to positive, akan ada potential, so the charge flow. So from this electrical device, okay, electrical device ni contohnya kalau saya bubuh sini basically lamp, okay, lamp ke, atau saya bubuh sini any let's say contoh apa, any other application. Okay, contoh application yang saya bubuh kat dalam sini asalkan it consumes the energy and converts the energy to heat, then it's a viable application atau electrical device lah. So bila saya bubuh electrical device, I want to see, okay, saya nak tengok okay, the work done by the charge. Kenapa saya nak tengok the work done by the charge? Kenapa saya nak tengok? Sebab bila ada pergerakan from here to here kan, okay, from here position A let's say to position B kan, the charge does work. And kenapa work done ni penting? Sebab energy is the ability to do work. Okay, so when you do work, it is said that you expand you punya energy lah, ataupun there's a conversion of energy lah, which we will see here. So how do we get work? Okay, remember back from chapter 1, potential. Okay, potential equal to the work done in bringing negative charge from the negative terminal to the positive terminal per unit charge, the work done in bringing a charge. Okay, so I know V is equal to W over Q. Okay, as you can see here lah. Okay, so I can rearrange this into work equals to QV, ataupun let's not use Q ni sebab agak confusing, nampak macam test charge, so QV. Okay, so this is the work done in bringing my charge from point A to point, let's say point B. Okay, saya nak gerakkan charge saya kat sini. Okay, so what else can I do for this equation? Okay, as you can see from here jugalah. Okay, I know that the current flow here, the current I will have an equation of the charge over time. Okay, so sekarang ni saya nak tengok, because when we talking about power ke, when we talking about energy, we usually need the quantity time. Okay, kita tak akan kata okay, saya habiskan tenaga 10 joule. Okay, kadang-kadang you habiskan tenaga 10 joule tu, ataupun you're doing work ke, power ke, it must be have a quantity of time lah here. So I can rearrange this, okay, into Q equal to IP. Okay, so this is tadi equation 1, so this is equation 2. So I can sub 2 into 1 so that I can have my quantity of time ke dalam my work equation. So I can get work equal to ITV, or I can rearrange back into VIT. So what is this equation? W sama dengan VIT. Okay, so this is actually the work. Okay, work done in moving a charge, okay, in an electrical device. Okay, however, okay, so bear in mind bear in mind, katakan kita tengah menggerakkan kita punya charge kan, kita punya charge tengah gerak dekat dalam kita punya electrical device ni lah. Okay. Bila dia gerak dalam electrical device is made up of, let's say, ion and also molecule lah kan. Okay, ion and molecule. Okay. So bila dia melakukan kerja di dalam electrical device, it's moving and it's probably hitting, okay, akan langgar, okay, this molecule and this ions, and it will vibrate. So actually when it vibrates, okay, it's actually converting, okay, the energy that is gained by this charge to, dia akan transfer the energy, okay. So the energy yang benda ni ada, okay, yang kita punya charge tadi ada adalah our electrical energy, okay, electrical energy, and it's doing work while tengah menembusi kita punya electrical device. So when it's doing work, actually it's transferring, okay, transferring the electrical energy to our molecules and ions. So actually it is converting our electrical energy to heat energy by doing this work. Okay, so the work we are doing here is actually converting our electrical energy to the heat energy. So what we can do is, actually we can write our W is equal to H. H ni apa sah? So H ni is the heat energy. Okay, remember again, because energy is the ability to do work. So bila kita dapat equation work kita, work equals to VIT, okay, the work done in actually moving this charge, okay, so we're actually converting this electrical energy to heat energy. So the work done here is actually the heat energy lah. Okay, work equals to H, which is our heat energy, which is equal to VIT. And because we know that V is equal to IR in ohmic punya device ataupun metal lah kan, so when you substitute V equals to IR here, dia akan jadi I square RT as kita punya heat energy ataupun kita punya work lah, okay, depending on which you use. Okay, so just a short recap. So tadi kita belajar on how we get work done inside an electrical device, and the work done here is to convert our electrical energy to heat energy. So when we found out the work here, okay, kita dah find work equals to our potential times the current times the time. So actually, since energy is the ability to do work, when you're doing work, you're actually converting you punya electrical energy to kita punya heat energy. So equation kita pun daripada work can be changed to heat energy, which is VIT, ataupun, okay, first version ataupun the second version is I square R. Okay, so that's all about energy lah. Okay, the heat energy depends on time, depends on the resistance of the electrical device, and also depends on the current which is moving through the electrical device. Okay, so got that out of your system. Sebab ni energy, I don't think I have to talk lah. It's joule. Okay, dia punya SI unit, and then it's a scalar quantity. Okay, scalar quant. Okay, scalar quantity. Then let's look about powers. But usually when you're talking about electrical energy, we're talking about power. Okay, so what's power? Power is defined as the energy liberated per unit time in an electrical device. Like I said, daripada kita punya heat energy tadi, and also kita punya work, we are relating time here. Sebab kalau kita guna electrical device kan, okay, kita nak tengok electrical device tu, okay, dia 10 joule ataupun dia 10 watts. Tapi in that quantity, kita nak tengok juga masa yang di mana the energy is used ataupun the power is used lah. Okay, so power here is defined as the energy liberated per unit time in an electrical device. Okay, so how much of the energy, which is our heat energy here, okay, ataupun how much the electrical energy tu yang dah di-convert itu, our heat energy per unit time. Okay, so here power is equal to energy per unit time. Okay, tapi macam saya kata apa, we're using the work to convert our electrical energy to heat energy. So actually you can also write this down, W over T. Okay, so which you have here lah, VIT. Okay, so equation kita dapat tadi, okay, work ataupun the energy here, nak tulis H ni pun tak apa. Okay, both of them are in units of joule, so it's still the same. So VIT over T, which cancel out, so you dapat you punya equation yang you suka waktu zaman sekolah guna, power equals to current times the potential in an electrical device. So when you see 25 watts, dalam you punya device yang you nak beli kan. So that power 25 watts is due to the potential, okay, the potential that the charge travels in the device and also the current flowing through the device. Okay, so it's scalar quantity and the SI unit is in watts. Power kan, you learn this dalam semester pertama. Okay, so because we know that our usually electrical device is an ohmic punya device, so usually you can apply V equals to IR. So this equation is the version yang pertama. So when you masuk V equals to IR, you akan dapat P equals to I square R, which is our second version of power, which is relating to the resistance of the object and also the current flowing through the object. The third one, where you can rearrange kita punya ni into I equal to V over R, dimasukkan I equal to V over R into kita punya equation yang pertama. So kita akan dapat P is equal to V square over R, which relates now the potential traveled by the charge in the electrical device per the resistance of the electrical device. Okay, so where can we actually use this? So let's try to doing question 12 together lah. Okay, so hopefully before we try to do it, you pause this video, try to do it first before we do it together lah. Okay, okay, so harap you guys dah pause the video for us to do. So this question, okay, figure 3.10 shows two resistors 42 ohms and 64 ohms are connected in parallel. The current through the 64 resistor, which is this one, is 3 amps. So dia minta determine the current in the resistor of the 42 amps. So sekarang ni dia minta I of the 42 amps. Okay, so this is the standard yang di mana, okay, apa kalau kita, sebab ni parallel, kita cari kita cuba cari R effective. Okay, tak, you nampak ini parallel kan. So in parallel, you should know that the potential is the same. The amount of charge which moves from this point to this point should be the same as this point to this point. Okay, so using V is equal to IR, let's try to find the V. Okay, jom gunakan ni lah. Okay, the top part, sebab dia dah ada I, dia dah ada R. Okay, so the I is 3, okay, the R is 64. Okay, so you can have a potential, okay, potential of 192 volts. Okay, the work done in bringing the charge from, let's say, point A to point B per the unit charge lah. Okay, so when you have this potential, what does it mean? It means that daripada sini ke situ, okay, punya potential should be the same from here to here because it's parallel lah. Okay, so then bila kita dah tahu potential dua-dua ni sama, so I can use V is equal to IR and rearrange it into I equals to V over R. Okay, sebab dia adalah parallel, so the potential should be the same. So 192 divided by our 42. Okay, 42. So we get here, okay, we should get here 4.57 amps. Okay, for our question E. Now let's look at question B. What is the total power supplied by the two resistors? Okay, before I begin further lah, okay, power kena jaga-jaga tau. Another way where the question can ask the power, katakan soalan minta the rate of heat energy. Okay, so when you see the rate of anything, rate tu is always per unit time. So rate of heat energy is actually H over T lah, which is also power. Ataupun dia soalan minta find the power dissipated. Okay, power dissipated. Dissipated. Okay, never mind lah, salah je. Tapi if you see power dissipated, it means that soalan tu minta power lah in general. So another way you can ask is rate of something, rate of energy, and also power dissipated. So let's look at this question. What is the total power supplied by two resistors using P is equal to I V? Okay, let's try to use the P is equals to IV. Okay, but now kena tahulah. Okay, so bila soalan minta total power, okay, total power means that dia minta the total tenaga of this both resistor lah. So when you want to use P equals to IV, okay, kena jaga the V here you can use is the same as the 192, tapi the current travelling to both of these resistors is not the same kan. Okay, because it's in parallel. So what you need to do is you need to find the I total. So how do you find the I total here? The I total here is basically I 64 ohms add by the I of the 42 ohms. Okay, because it's in parallel, so you just add the individual current lah. Okay, so you get here 3 plus 4.57, so you'll get here 7.57 amps. Okay, so that's the total current traveling through the top circuit here. Okay, so P equals to IV, so kita akan dapat 7.57 multiplied by the V. How much is the V here? So the V kita tadi berapa? 192. So you can get our total power of 1453.2 watts. Okay, so 1453.2 watts, or we can say that there's 1453.2 joules per 1 second. Okay, for 1 second, we can say that. Okay, so this is the amount of energy dissipated by the device lah. Okay, so that's how you do question number. So bila you nampak ni, it means that the current and the potential flowing through the charge will give the power of 1453.2 watts. Okay, kalau dia bagi time pun kat sini, kita boleh tengok lah macam mana at a specific time how much is the energy, okay, how much is the heat energy going out. Okay, but soalan ni tak bagi time, so tak apalah. Okay, so for our next class kita tengok potential divider. Hope to see you soon. Bye.